Say we have a feasible tree solution X star. We want to obtain a strongly feasible tree that determines X star. Recall that the definition of a strongly feasible tree requires a root node, and we'll use R to denote the node that is chosen to be the root. So let's say that the tree that determines X star is not strongly feasible, and we let T to denote its arc set. A tree arc EJ is called bad if the flow value on that arc is 0 and EJ is not directed away from R. So let's say this is our tree. And what we'll do is we'll define a node set S to contain all the nodes that are joined by a path in the tree to the root that does not use any bad arc. If S contains all the nodes in the network, the tree is strongly feasible. So that's not the case. Then what happens is every tree arc that goes into S must be bad. So here, if we look at this arc going in, these have flow value 0. We'll now consider two cases. Suppose that there is an arc that comes out of S. In other words, delta plus of S is non-empty. Note that by the definition of S, this cannot be a tree arc. We add this arc in, and so we'll have a cycle formed with the tree arcs. And this cycle must contain a bad arc that goes into S, and we'll remove that bad arc. So we end up with a new tree. And now if we grow this set S again, it will get bigger because the head of the arc that we added in this picture is EK will be in S as well. If we can do this repeatedly, S will keep growing, and since there are only finite number of nodes in N, the process must stop. But it is possible that at some point, delta plus of S is empty. In this case, there cannot be any strongly feasible tree, but the network can be decomposed in the following sense. It can be shown that if you add up all the supply values in S, you'll get 0, and for every feasible flow, X prime, the sum of the flow values on arcs going to S will be 0. In other words, no arc in delta minus of S can take positive flow value. That means that every arc in delta S minus is useless. We can remove them. After remove them all these arcs, we'll end up with two pieces. One piece is on the nodes in S, and the other piece is on the nodes not in S. And we can solve the minimum cost flow problem on each of these smaller pieces.